So welcome to our second AWS User Group in Bratislava this year. Today we'll be discussing the topic of cost optimization. It's something that is heavily discussed nowadays. Of course, everybody needs to look at the budget and save costs, and it's something that we deal with our clients as well. So we prepared 3 topics.
So my name is Martin, and as Laura said, today I want to tell you something about continuous cost optimization, and especially the ways how we do it for our clients. First of all, let me introduce us as a company. So probably a lot of you have already heard about us or have been talking to us, but we as a company are basically a one-stop shop for DevOps Cloud and Kubernetes. We have been doing it for 7+ years at this point, and what we basically do is that we design and implement cloud infrastructures, mainly in AWS, mainly around Kubernetes, serverless, and these sort of topics which I'm sure you are familiar with. Currently, there's around 20 people in the company, and we are managing already 100+ Kubernetes clusters to our clients. We state that our mission is to transform businesses to become cloud native and future ready, and by doing that, we essentially want to enable their growth and to help them scale their business and grow their businesses as a whole. So, I'm sure that a lot of us, when we started working with cloud, looked similar to this. I believe when you start using cloud services, it's all like sunshines and rainbows, everything works nicely, and it allows you, it gives you access to a gazillion of services, enables you to iterate quickly, and you can move very, very fast. But at some point you can get the cloud bill, and at that point you might have this feeling. And most likely you're not really sure what's causing it, or how to tackle it, how to mitigate the problem, and what to do about it. And that's basically precisely what I want to talk to you today about. The presentation is divided into several parts. The first one, which I want to focus on, is cost optimization as a topic, and why it is interesting, why would you even want to talk about this and think about it. And by that, I would like to start with some numbers, because that can give you some perspective about the current situation in the cloud world. And it is estimated that by 2028, the cloud computing market will surpass $1 trillion, just to illustrate the scale of what we are talking about. And maybe to get a better understanding about how this topic is growing over time, just between the years of 2010 and 2020, there was a 635% jump in cloud computing market. So this is just to illustrate how the cloud is currently a theme for everybody, how it is a topic that people are addressing, and how costs in the cloud are becoming more and more significant as a topic, and a lot of people will be challenged by this. Another interesting statistic is that it is estimated that only 3 out of 10 companies know exactly where their cloud costs are going and what is causing them. And this is a pretty similar experience that we had with our customers. A lot of them are in the cloud already and they are paying for some services, but a lot of the times they are not really sure why the bill is so high or what it is caused by. So this is something that we have been in contact with as well. Year over year, the cloud spend is growing on average of 35%. This is again something that we have seen across our customers as well, mainly because they are growing as companies in the cloud, and therefore they are also growing their usage in the cloud of the resources. But the more interesting numbers, in my opinion, are that many organizations waste almost 32% of their cloud budget. And the reasons for that can vary. It can be because they are using underutilized resources, because they have some technical debt which is causing them to run some workloads that do not have an owner, and everybody is afraid of turning it off and things like this. But there are a lot of topics that we can discuss today why this number is so high. And one of the methods for addressing this issue is right-sizing our infrastructure, and that's something that we will talk about today as well. But an interesting thing is that alone can cut your costs down by 46% on average. And I would like to end this section just with a statement which I think is really true in this world, and that high cloud infrastructure costs are not really a disease or a problem itself, it's just a symptom. And it can be a symptom of many things that we can identify together today. But it is not the problem itself, it's just something that shows up when you actually have an underlying problem that you need to address. Now the second part is to discuss cloud costs as a problem, as something that we actually want to tackle, as something that we can mitigate, as something we can fix. So let's talk about that now. If I would give you one single advice on how you can save money in the cloud, it would be to turn things off. And that can sound funny or stupid, but that's actually very true. One single way of how to save the most money in cloud is just by shutting unnecessary workload off, and that can be in various ways. We see a lot of the times that companies have been running some legacy services for a long period of time, and they basically lost track of them. They do not have an owner. Everybody is afraid to touch them. Nobody knows who created them, and they are just want to keep them running. And that can be a good example on how to start and how to make some significant savings, is just to figure this out and turn it off if it is unnecessary. Another way would be to enable better scaling, for example, because if you're running underutilized instances or underutilized workloads, that alone can cost you some amount of money. A good way to go about this is that we can, with cloud, we can really utilize the pay-as-you-go model, and the way we utilize it is by efficient scaling and by efficient utilizing of the flexibility and scalability of the cloud itself. Within AWS, and I think this is true for most of the other cloud vendors as well, there are three main drivers of cost. The first one is compute, meaning EC2 instances, RDS databases, Lambdas, anything that you use to run your workloads on. The second one is storage, which in terms of AWS can mean S3, EBS, CFS volumes, anything where you store the data in, or even snapshots of RDS databases and things like that. And the third one, and I believe the most complicated one, is outbound data transfer, or data transfer in general. And the way that is priced and that is built to a customer can be really confusing and complicated, and identifying which services are causing the data transfer bills and how to optimize that can be really challenging. For each of these three drivers, you need to identify what's causing the spike in costs. And for that, we believe that observability is really the key to understand that. Observability as a topic is something that I think is very known to everybody at this point. We basically use observability to track and identify important metrics and to better understand their change over time, or even to correlate different metrics. And that can apply to the application level, that can apply to the infrastructure level, but that can also apply to your build. Because when we start a discussion of cloud optimizations or cost optimization with someone, we basically are trying to identify some irregularities, something that changed over time. Often when we start this discussion, I ask for a couple of months of their AWS bills just to see how the services that they are using are performing, and if there are any underutilized workloads, or if there are any metrics that would indicate where we can actually make some savings. And those can be pretty obvious, if you look at CPU utilizations or something like that on your databases, but they can also be something like if your databases have an ongoing connection to them. And if you have a database that did not have a connection in the past week, that can maybe mean that you can shut it down. That could be an interesting way to figure that out. The point is that we want to make sure that we know and we understand what we are paying for in the cloud. And that's the observability as the means for doing that. Another interesting topic is that costs in general do not necessarily have to relate just to the cloud bill. Technical debt is something that can be also a huge cost driver, and that can generate costs on many levels. If you have accumulated a lot of technical debt over a long period of time, that can cause you to have outages, that can cause you to have a big AWS bill, that can put a lot of stress and load on your DevOps team or the people managing your infrastructure, and overall that can just result in a lot of production issues, a lot of outages, performance problems, and everything like that. And indirectly, that affects the revenue of the company. Like if you have an outage and if you are a e-commerce system that sells some products, having a single outage can mean cause a lot of money to you. So like cost optimization can have many forms, not just the bill itself, but also things like optimizing or eliminating some technical debt, streamlining operations, designing a better architecture that is more resilient to outages and things like that. The usual procedure which you can start when you want to make some savings on your cloud bill is to analyze your infrastructure. That can mean like taking your AWS bill, looking at it, what are the most like significant cost drivers, what are the services that are causing you the most money, and you can figure out if there's something that you can shut down immediately. Usually there's something that you can. And then another easy step that you can make is to buy some reserved instances for your databases or purchase some compute saving plans for EC2 instances. And that basically means that you make some commitment and you purchase something in advance and you basically commit for some period of time. In case of AWS, that can be 1 year or 3 years, and you decide if you want to make some upfront payment or not. And that can give you a saving on average on about 30%. That's something that we can see. We are usually talking about these numbers. Another interesting thing, and this is something that we utilize for most of our customers, is using spot instances, which is basically some capacity that AWS is able to provide to you at a significant discount. We are talking about 60 to 70%. But the catch is that they can take it from you with a 2-minute notice. So you really have to design your architecture and design the infrastructure to be able to accommodate this. So what we do for our clients is that most of them are running on Kubernetes, and therefore we can pretty easily utilize this benefit of having spot instances if their applications are able to tolerate it. And that way we can make an additional savings, so we are at about, let's say, 60 to 70%. Another thing, what you can do is right-size your application. So look at the metrics that you use, look at the load that it usually has, and figure out if the resources that you're requesting are actually appropriate for the application. If it is not underutilized, if it is not overutilized, choosing the right types of instances, compute or memory optimized, or if there's a specific CPU that works better for your application. Those are all the things that you can use to optimize the bill as well. And then the most complicated one would be to do some refactoring of your application. And that can have many forms. Like that can mean, for example, choosing some different execution engine for, let's say, your PHP workload. You can switch from PHP FPM to something else, which is more optimal. That can mean to identify some unoptimal queries to your database and like refactoring them to be more performant, or anything basically where you can make some improvement and improve the performance and therefore also the cost. And then when you do this, you basically observe, you analyze, and you do it all over again. Another interesting point is that cost visibility, meaning that you actually know what is causing the cost, does not automatically equal cost accountability. And by that I mean that cost visibility tools don't really bring cost accountability to different teams automatically. And what we found out over the time, that presenting costs to the individual teams which are taking care of the applications and developing them can have some significant benefits as well. Because if you give developers, engineers, and the team, like platform teams, whoever is maintaining and managing the infrastructure, some metrics that they can see that can relate to their costs as well, can mean that they want to improve it and they want to make save some money on their own. But the way you present it has to be meaningful. Like it has to be simple. They have to understand it. You cannot like give them the whole AWS bill to analyze, but you can give them some good metrics, some service level indicator to calculate. And that can, for example, mean cost per booking, cost per user, cost per tenant, cost per player, something like that, which they can easily identify and which they can easily try to improve over the time and therefore decrease the overall cloud bill as well. When you want to migrate to the cloud, what we usually try to avoid is lift and shifting, meaning that you have some on-premises workload and you want to just move it to the cloud. That's something that will 99% of the time will not provide any benefit for you whatsoever. It will just cost you more money. It can be more flexible, but if you don't make any architectural changes to the infrastructure and to the design of your infrastructure, it will most likely cost you more money than before. So what we do for our customers is that we try to refactor the architecture of the infrastructure. We advise them on refactoring some code. And that can mean, at least at the start, that you are putting more effort into it, that you are maybe spending more money at the start, but over the time, that can lead to some huge savings in the long run. So our advice would be to optimize your code early. Now, the third part is more technical, so we can actually deep dive and see some cost optimization techniques in AWS that we can use, and some cases that we have been actually free. First of all, and the most obvious one, I think, is elasticity, because that's why we use cloud in general. As I said, most of our customers are running in Kubernetes, so what we are able to do pretty efficiently is to scale the clusters on their own. And there are many ways on how to scale them. The point is that most companies and most applications will not have constant workload. It's never a single constant line that never changes. It can change depending on your user base. It can change depending on your jobs that are running at night or processing something, but almost never it is not constant. There's always going to be some lows and highs, and Kubernetes or cloud in general can allow us to scale based on that demand. And Kubernetes as a tool is especially good at doing that. There are also some additional savings that you can make when you scale. As I said before, you can utilize something like spot instances if you can. But you can also utilize some interesting tooling. AWS have developed a tool called Carpenter that we use for all of our customers, which is essentially a different or an alternative implementation of Cluster Autoscaler. And that tool alone can introduce some performance benefits of scaling, but also, for example, pick out the cheapest instances at that time. And that alone provided around 20% savings for our customers, just migrating from Cluster Autoscaler to Carpenter and letting it choose the cheapest instances at that time and allowing to more efficiently pack the applications together by giving it the flexibility to choose the instance size and the instance family, introduced around 20% savings for our customers. So this is something that I would definitely look at. This is an example from one of our customers. When I was talking that most companies do not have constant load, this is the exact example. You can see how this is a Kubernetes cluster and the number of worker nodes. You can see how it changes during the day. And even if you have some events, it can grow multiple times during the day. And even if you have some events, for example, a gaming event, you're selling some item at a specific time. A good example is a football match that you experience a lot of viewers at a single point. And the elasticity of the cloud can really help you scale, meaning that you don't have to have the infrastructure to accommodate that peak ready at all times. Another good example is pre-scaling or event-driven scaling for incoming load. This is a screenshot from one of our customers that has a very big load. Every 2 weeks they have several million users at a single point, and then the rest of the time they have nobody there. So what we do for them is that we know where the event is happening and we just pre-scale the infrastructure for them. It takes some time to do it, especially at the scale, but what you can do is to efficiently just anticipate the event and scale the infrastructure in advance. Or you can scale based on some events, for example, or metrics, for example, number of messages in the queues, something like that. And the scaling can happen when you are enlarging the infrastructure, but you can also efficiently scale to 0, for example. If you have workers that are consuming messages from some message queues, maybe there are times that there are no messages at all, so you can scale to 0 and you can save some money just by not running the workers at all times. And a nice tool for that is, for example, Keda in Kubernetes, which allows you to do this. Now, right-sizing is another topic that you can address. As I said before, like oversized resources lead to unnecessary costs, so you really want to like fine-tune the setup that you have. But like, how do you do it? There are several, I think, methods for doing this. For us, if we have a customer that is migrating to the cloud and doesn't have anything there, a nice way to do it is to perform some sort of a load test. So you actually like simulate a load on the application, maybe even a lot larger than you would usually anticipate. And that way you can identify some bottlenecks, like what will be the resource preventing you from scaling further. Usually it can be some like CPU-bound applications, it can be a database, it can be some issues with I/O operations on the disk. So you, with load testing, you can really like find the bottleneck, but also figure out how the application is performing and how to improve it. And you do it several times, and that way you can figure out the best setup that works for you, what instance type performs the best, etc. Another option is to launch the production and like look at it after some time and like try to optimize the resources. When we migrate to production, when we do a migration, we usually oversize it at the start just to be safe, basically. But afterwards, when we have the data about the utilization, we can like come back and fine-tune the resources, play around with it, and try to find the most optimal setup. And that can mean adjusting like resources that you're requesting for CPUs, for memories, for instances, but also trying to find the sweet spot for scaling. Usually it's around like 70 or to 80% of the utilization, but for some applications it can be smaller, for some applications it can be larger. So this is also something that you can play around and try to optimize in regard to the cloud. And the interesting part is networking or traffic in general. And this is something that some people do not realize that is a significant cost driver as well. In general, like egress traffic going out of AWS is really expensive. Like if you put data in AWS or in any cloud, it does not cost you basically anything, but if you want to take it out, it can cost you a lot of money. So there are various approaches that you can utilize to optimize the egress traffic or the traffic in general. I think the most obvious one is to utilize like a CDN offering like Cloudflare, CloudFront, or some alternatives, which can give you some also like performance benefits because you are caching the data at some edge locations close to the users, but the traffic from there is also cheaper. So this can be the most like easy change that you can make in regards to traffic to improve performance, but also to save some costs. If you are moving data between AWS services, so for example, if you are putting data into S3 or like DynamoDB or whatever, you can utilize a service called VPC endpoints, meaning that you do not access the AWS service through internet, that you do not go from AWS to internet and back, because that way you will be charged. But you go for a dedicated service for that, which I believe is free. And if possible, there are things that you can use, like enabling compression, for example, just to like lower the amount of data that you're transferring, utilizing caching on like devices of your clients or like methods like this, which are quite common. A very interesting topic is cross-zone traffic, and that's something that's especially hard to tackle. Cross-zone traffic is basically something that happens if you communicate between availability zones. So like each region in AWS has, well, most of the regions have multiple availability zones. And if you have services running in multiple zones, which we usually do, especially because we want to ensure that our services are highly available, you have databases with multiple replicas, what happens is that you have a lot of cross-zone traffic, and that is something that AWS charges you for. And like identifying what services are causing the cross-zone like communication and like pinpointing how you can optimize can be really hard. You can utilize something like VPC flow logs for that, but still it's a pretty like daunting task. You can also try to refactor your applications not to generate that amount of load, but again, that's something that's can be quite complicated. But there are also like easier things that you can do. In Kubernetes, you can use topology over routing, meaning that you can like prefer services in the same zone or even on the same node, and that way eliminate some amount of cross-zone traffic at all. Or you can even like try to keep workloads in one zone if it is not absolutely necessary to have it like distributed across multiple ones. Another topic in networking is NAT gateways. If you are using like a managed service called NAT gateway, which you use if you want to reach out to the internet from private subnets, it's a service that is built by hour just for running it, which is not that significant. But it is also built per gigabyte processed. And that alone can, again, like cause some significant bills for the network traffic, especially if you are a company that transfers a lot of data. And we had several customers that were transferring a lot of data through NAT gateways. And one interesting tool that we found to mitigate this issue is called Alternate, which is an open source implementation which basically deploys a set of highly available EC2 instances, which you can use as NAT instances instead of NAT gateways. And you don't really pay the price per gigabyte for NAT gateways, you just pay for the data transfer, which you do anyway, even with NAT gateways. So this was really like optimizations that we often offer to our customers for like optimizing NAT gateway bills. Another interesting topic are databases. So databases can be hard to predict how they're going to look in 3 years, especially like if you're a startup, you cannot really be sure how your company will be performing in 3 years. So if you're buying along, you can always buy reservations and save some amount of money, but you have to commit to a year or so, and that might not always be easy. One way of like optimizing database pricing can be scaling the databases as well, and that's something that we have been looking at recently, like to scale RDS databases based on demand or based on anticipated peaks, because RDS allows you to have multiple replicas, you can scale pretty efficiently, and you can do a simple failover to switch to a different instance. So that's also something that we have been looking at and like figuring out that we can use on-demand RDS instances instead of reservations and achieve similar numbers in regards to price. But what you can also do is to pick a different flavor of the database. RDS allows you to use like the standard edition where you pay for storage, instance, and I/O operations. But it recently, or last year or something like that, introduced like an I/O-optimized version where you pay more for storage and instance, but you don't pay for less for I/O operations. And like if you're a company that utilizes databases in this way, just by switching to this instance type, which essentially means zero changes for your applications, can introduce some significant savings. This is a screenshot from one of our customers. Another interesting topic is looking at refactoring your applications or looking at like different optimizations at the application level. For one of our customers, which was a company like having a lot of backends written in PHP, they were using PHP FPM in Kubernetes, and like it was working okay, but we knew that it was not performing that well. And we looked at for essentially swapping PHP FPM for something else. And there are several alternatives. There's a tool called OpenSwool, there's a tool called Franken PHP, which should be more optimized than the PHP FPM implementation. And just by switching out this PHP backend, which can mean that you have to make some application level changes, but that does not necessarily have to be that significant, saved us between 70 to 80% of our needed replicas, meaning that our infrastructure shrank to 20% of it from size, and we even gained some performance improvements. This is a diagram displaying like requests per pod, which we were able to do between the deployment of PHP FPM and moving to Swool. So before we were around like 10 requests per second, and over time we grew to like 60 or something like that. So this is something that can take some effort to do, but the overall savings can be significant, and you are not even committing to any reserved instances or anything like that. This is basically the same thing with latency. So just by switching to OpenSWO, we were able to lower the latencies and therefore like improve the performance of the applications, I think, by 50%. And overall, what I would say is that like cost optimization is not easy. It's a complex topic which has some like easier things that you can do at the start that can lead to some complex topics at the end. But I believe it's worth the effort. Like if it is something that we have to do continuously for our clients and something where we, especially at these times, have to look at more frequently and have to optimize the cloud bill. So it's really not a one-time effort. It's something that you do over time. You repeat the process and you try to optimize because the infrastructure is evolving over time. The applications that our customers are using are evolving and they are changing. They are introducing new services. So this process basically never ends for us, and we always repeat it and always try to improve. And that would be all for me. If you have any questions, now would be good time to ask.
I'm wondering if there is something like a healthy number for a healthy cost. Like, let's say we are running SaaS business or a product. Do you know if there is something like optimal cost, like I don't know, 5% of revenue or 10% of revenue, and how it scales? Like, let's say you grow from 1,000 to 1 million users. I am hoping that the cost optimizes not growing linearly, right? But it will drop. So do you know?
I'm not sure if there's a number that I can say. Like, I think this can depend on the business model and everything like that. So I'm not sure if there's a figure that would illustrate this. But as you said, the price for cloud should not be linear. Like it should decrease over time by the number of tenants, and that's something that we have seen for our clients where we build SaaS solutions for them. So we had a lot of clients that basically were selling like software as a single tenant instances, or you could purchase it and deploy it on their own, and they wanted to build a SaaS. And what we did for them is that we were able to calculate, for example, price per tenant, how much one tenant would cost, and estimate how that would lower over time. Because at the start you have to have some base infrastructure to run it, and even if you deploy any empty infrastructure, it can cost you $1,000 or something. But as you grow and as you incorporate more and more tenants into your SaaS solution, the cost should decrease and the price per tenant should be lowered.
Yeah, I just wanted to say that if you are paying less, then what you earn, I think that's healthy. You can also
That's a good start, yes. Okay.
You mentioned using spot instances. What's the ratio between the regular ones and spots before things start to get shaky?
We run, most of our clients run 100% on spot instances. Because what we are able to do is that with tools like Carpenter, you can have like backup solutions. So when there are no longer spot instances available, they can fall back to on-demand ones, and they can like add new instances as needed. So most of the time we run 100% on spots, unless there's an application that prevents us to do it. So unless you have some application that is not able to terminate within 2 minutes, gracefully, that can be something that can prevent us running on spots, but our default is to run everything on spots. And we have been like doing it for 4 or 5 years with like 90% of our customers. We have no issues with it. Because you run multiple replicas, like you still have, your application should be distributed to multiple nodes, so it should have multiple replicas, and even if one instance goes down, we don't really care. There will be a new one in a minute or so.
But yeah, still there is a low, but still some percentage of or some probability that AWS will try to revoke all your instances.
That's really a low chance.
Maybe it's really low, but still there.
It is still there, but it's so low that we have never encountered something like that. And Carpenter is a tool that also takes into account the probability of termination of that instance type. So when it chooses an instance, it looks at its price, but it also looks at what is the chance that this instance then will be terminated. And you will never be using the same instance family in that case. Like you will have multiple instance families, and the chance of, especially if the infrastructure is larger, of AWS terminating all of your instances at the same time is so low that you don't really have to worry about that. If you run 2 instances at the time, yeah, that might be a valid case to run on demand. If it is so small that terminating one instance would cause you some problems, that would be a good reason to run on demands.
In regards to spot instances, what's the percentage of the termination from the pool?
That depends on the instance family and region and everything like that, so I don't really know, but there's a good web page that like shows you real-time termination percentage of like spot instances. I don't remember the name, but I can show you afterwards. It's highly dependent on the region as well. We see that, for example, in Ireland, some specific instances can be terminated more frequently than in some like more exotic regions, for example. So it depends. We had issues when we were running like dev clusters on T3 instances on spots, and we were like doing upgrades and rolling out the whole cluster. We were lacking some instances and had to fall back to a different family, for example. So for us, for example, T3 or some like common versatile instances can be something that can be lacking at sometimes. But the nice thing about Carpenter is that you don't really have to care, like it will pick up a different one. So, or like at events like Black Friday, for example, when you have a lot of companies scaling at a single point in time, you can always fall back to on-demand for it. Like if there are no spot instances, it will spawn on-demands for you. So that's nice.
I will just add it's not true for GPU instances. There are no, like majority of time in Dublin or Frankfurt, no spot instances.
Yeah,
so it's true, but for non-GPU.
Yeah, that's true. And we also like when we scaled when I showed the screenshot with the high peak, we are also scaling the databases there, and like we wanted the largest Aurora database available, and there was no available instance at the time. So for like specific instances or specific workloads which are not common, that can happen.
Also, Frankfurt is quite overcrowded. Like everyone is going to Frankfurt in Europe, and they are like struggling with that. Like if you can pick Ireland, and they have quite a lot of space up there. And the other thing is that, like, from our point of view, when we first started using spot instances, it really looked scary that, like, the instance can shut down any time, practically without any notice. But at the end of the day, it's a good thing. Most of the instances will clean themselves, and right now, like, we are looking for ways how to make sure that every instance will shut down every 48 hours, because it's better for the cluster.
Okay, any other questions? Okay, if not, thank you, and I will be around if you want to answer other questions.
Mihál, so just super quickly about me. So for years I worked as a data scientist. I studied artificial intelligence on Mathis. Currently I'm focusing on integration of data product in the cloud and sometimes also on-prem. Officially I'm product owner of cloud data delivery and computation team in Solargis. And what I mostly love on the cloud generally is serverless, because I love more like providing the real value for the customer, not really hassling with the infrastructure around. So just super quickly about Solargis and AWS, because we have a couple of services, but on the cloud is still just few of them. One is Prospect, where we're using a couple of technologies like S3, Dynamo, Lambda, SQS, CloudWatch, and so on. It's already in production for a couple of years. Other is Evaluate, where we use much more tech stack, except those I mentioned. We use ECS, auto-scaling groups, step functions, Kubernetes, and we use heavily EC2 GPU, which I will talk in demo basically. Generally about Solargis, we do with solar data. I think that's enough for this meetup because you are not here for the product, right? So, and last sub-product is business intelligence / monitoring, which we also run on AWS, where we use Glue Crawler, Athena, and Quicksight, which I will also talk in context of cost monitoring. So, as you probably know, the AWS provides a huge number of services. I just mentioned like 20 of them, which we are using. This is a relatively small company, so just good example how big this distinct number of technology you can use. And my favorite thing about like pricing is this. You know, the cost star in the Lambda is famous, right? But my question is, do you think you pay for init phase or not? Who think yes? Who think no? Or other? And it's tricky because depends. If you are running Docker image, you pay for the Python Docker image, so you need to use ECR Python Docker as a base. You pay for the init phase. If you are running typical Lambdas, without Docker, you do not pay for the init phase. So this is just an example how complicated pricing and billing in AWS is, because somehow to take into consideration all the stuff like 3 tiers, data transfers, as Martin mentioned in previous talk. They provide all units like VCU, ECR in the Dynamo, right? So it's really complicated and to predict, you know, if you see some architecture, to predict the real number of your costs is, I think, almost not possible to say, right? Because there are so many variables, auto-scaling and so on, and to say some roughly number is okay, but to be precise, I think it's not possible. So this is the reason why everybody who has some normal spend on the cloud should really start to have real cost monitoring, you know, in the cloud. So basically, there is some definition of FinOps, but I will just say a few sentences about the FinOps. Actually, majority of these already mentioned Martin in the previous part. So, from my point of view, is the equal part is technical or business monitoring. So, you do not care only about your latency of the Lambda or some service. You do not care only about how many requests you are able to provide for a customer. You also care about the cloud bills, right? So it needs to be equally important, and it needs to have equal approach from the company. So ability for every engineer to zoom in, zoom out the data for the services he's operating, daily reporting, alerting, regular meeting, health check, you know, like some of the people, some tech leads check regularly, like monthly, weekly, the spends, the trends, and so on. I think it's must for any company who is operating in the cloud about some threshold. You know, you are not doing it if you spend €2,000, right? So, not the best. So, the problem, the native Cost Explorer in AWS is not really good for the main pillars I mentioned. Not sure if you work with that. It's okay for some super high-level image, but to go deeper into the particular data, hourly data, and so on, it's almost not usable, I would say. Maybe somebody would not really agree with me, but from my experience or from my tried, it's just really limited tool for the FinOps operation. And even AWS is currently recommending well-architected framework, something like Kudos dashboard, which actually deploy a couple of Quicksight billing dashboards into your account. And I will show today something similar because I will show how you can build it in your account for yourself and how you can understand what's really under the roof. So what is the Quicksight? Maybe some of you don't know the service. It's like business intelligence tool inside AWS. I think currently they are really pushing into this product. Like I was on Labyrinth in Vegas and everywhere was like Quicksight, Quicksight, Quicksight. Like they really want to everybody using that because it's, I think everybody is still using like Power BI and some other stuff, but you know, everybody's moving into the cloud, so they want to everybody using it. So the main advantage is like it's serverless, it's scalable. So there was the talk on the event that Mercedes built all their analytical dashboards for like thousands of customers on the Quicksight, and they didn't care about the scale or anything. So in comparison with other business intelligence tools, usually mainly those on-prem, it's much easier to set up in your cloud environment. Usually people are using Quicksight for business monitoring and data analysis, but from my point of view, FinOps is basically data analysis and business monitoring of your costs. So it really makes sense to use Quicksight. So why should I already mentioned basically a couple of pillars, so I should use, for example, Quicksight or other BI tool for building the data. In comparison with Cost Explorer is you can visualize the data, you can go into hourly granularity easily, you can interact with data, you can zoom in, zoom out, you can combine with the product data, as Martin mentioned, you can see your data from like Mongo or AWS next to your cost data, so it's actually what you want to see. You want to generate insights and actions. And one of the most important stuff you can give, for example, permission to your web apps team just about Dynamo or Lambda, cost, your CTO, you can provide all information and so on. So you can really play with permissions because it's really a major tool from compliance perspective. So also difference in comparison with like Cost Explorer. So there are two ways, as I mentioned, how you can build Quicksight dashboards about your billing data. One is pre-prepared solution. They call it Kudos. As I mentioned, it's part of the well-architect framework, and it's basically a couple of steps you need to do. I will show it actually in the last part of presentation, but I will show how you can basically do it on yourself, and but basically it's using same architecture as the Kudos dashboard. So at least you will quickly understand what is under the roof of that Kudos. So the architecture of the solution is actually not so hard. So the first important part is cost and usage report. So basically you can set up in your AWS account that you want regularly, on daily basis, put all your billing data into the S3 bucket. So basically it's easy to set up, I can show later, and it's regularly, continuously put all your cost data into the S3 bucket. Once they are in the S3 bucket, you can use AWS Glue. AWS Glue is a serverless tool which basically all the time check your S3 data. It's try to basically imagine what kind of format it has, so you don't need to really care about what kind of columns are in data in the packet which generated AWS anything. They will basically just read it, basically predefine the format, and they will save it into AWS Glue data catalog. AWS Glue data catalog is thing how you can basically query data from the S3 bucket via AWS Athena. So this is the typical, this 3, 4, 5, this is the typical technology stack in AWS, how you can actually query your data in data lake, right? So for those who work with any data lake technology in AWS, this is like typical way how you can operate your data lake stack. So with those three technology, you can in a couple of minutes actually have all your data in queryable way in AWS Athena, So you can, you can write SQL query on your data as any other data you know. So pretty cool. And where already you are in Athena, you are just one step to query data from Amazon Quicksight, because this Amazon Quicksight is an Amazon product. It's fully integrated and super easy integrated with AWS Athena. So basically 4 or 5 steps, and you got your data in interactive dashboards. We will show it soon. So just quickly recap. So in AWS account, or you can do it via CDK or Terraform, you can set up data export. There are multiple options: hourly granularity, daily granularity, with resource ID, and so on. So you need to decide what is best fit for your use case. Then, as I said, you set up crawler. You say which bucket you should actually check, and then you can schedule it. And for example, every day, every hour, but it doesn't make sense to every hour because you got your data every day. It check your bucket and create data catalog, which is queryable via Athena. And that's it. Now you can query your data as any data you know from your database carrier. You ever work with SQL. And even this, from me as a data scientist, I would say it's kind of actionable or powerful, because even without dashboards, you can query your data. Like somebody cares about EC2, somebody cares about Lambda, data transfer, anything. You can really go deep. You don't need to just look on some dashboard or something. You can really go super deep. For example, here is the query where I check the sum of the usage of EC2 instance in a given hour of the day. So you can do some even pre-warming or any other decision. But this is just example how deep you can go into the data. And that's it. As I said, when it's in Athena, it's in just a couple of minutes. You can use it in the Quicksight, and you can explore those data easily. And I can show it in a second. Other basically advantages you can, which I will show, you can, as any other BI tool, you can continuously send reports, alerts, you can join the data and share the dashboards with your team and so on. So my demo, I will basically show for what we are installing in Solargis right now. So we have the evaluate tool where we actually simulate the solar panels anywhere in the world in the last 30 years. And it's like super heavy for computation because we are using GPU simulations. And actually, for the huge GPU simulation, we are using hundreds of EC2 GPU, right? For the small simulation, we are using just like a couple of them or even a few on-prem. So we actually, any hour, we have like 0 or 200 EC2 machines. But as we have some scaling algorithm, and if it falls down, and we would scale all the time, we could have costs over $1 million per year. So that's why we needed to build some operation framework, to actually monitor / observe the costs in a really granular way, right? Because if we will fuck it up, it will be really bad for the bills. And this is just example how we differ, how huge variability we have in the spends for those EC2 machines. Of course, we are in just pilot program, so we have just almost no customer, and usually most of them are internals. But still, a couple of hours, we can be almost at 0, and then we can go to hundreds of dollars per hour. So we really need to operate it, and we really need to check it out all the time. So this is also interesting point because, for example, right now I care really about any hour costs. But for example, architecture, CTO, and other guys, they just care about like a weekly report and so on. And this is also super important aspect of this framework, because in Quicksight you can build one dashboard for team A, which care about technology B and C, but totally different dashboards for different kind of people, because everybody cares about different level of granularity, technology, and so on. So let's quickly just say how Quicksight works. So you have three hierarchy. First is that data set, which is basically, in our case, some Athena table. It could be also S3 data. It could be any other, it's just CSV, which you build then analyzes. We will show it in a second. And when you deploy analysis, you can have a dashboard which you can share with your colleagues or other people. So let's be practical. So as I said, we are in Quicksight. This is Quicksight. We already have data in the application. So as a first example, let's revisit what I mentioned. We care about EC2, right? So let's first build just for I don't know, tech leads or some CTO, some quick overview how much we spent. So on the EC2 instances, so we can have product instance type. We can have spend. You know, the data from the billing export actually contains more than 100 columns. So you need to little bit make a research. How does it work? But actually, usually use just few of them. So now I use start date. You know, it's like a billing date. I use spend and the product instance. You know, majority of our product instance is GP2 is large with a GPU. Now I have some, time series, but let's probably start with, we care about week time series, and we want to see that in like per week, you know, so we can see the real per week consumption. Let's probably add, I don't know what we will add, we can check. So yeah, just like general pie chart. So I can say instance type and basically color the instance type, the spend. So I will have quick overview how my actual accounts looks like. You know, your accounts looks like totally different because usually you will use some T instance or other. But this is like super high level overview. So for example, even now you can publish, and as I said, you can publish the dashboard, right? So we just create our first dashboard, which could be enough for, I don't know, some C position or some general people. So what you can do, you can share the report, and you can send the report to the person you want every day, every week, anything, and you just create first dashboards and reports in like 20 seconds, right? But now let's be a bit more deeper, because as I said, we really care about hourly spend, because as I said, it can differ a lot, like really a lot. So let's duplicate this sheet with time series. Let's use line chart. We can easily change it to hourly granularity, right? Because the underlying data are in hourly granularity. Let's, for these purposes, use just like was a couple of 5 days, and you can see that you're really like your hourly spend for the EC instances for the given hour. You can really easily play with, so you can add data label, you know, so you can actually see something. You can check with, you know, typical BI stuff like colors, e-axis and so on. So you can really create charts you wants to create for your purposes. But usually, what I really care is when I wake up, I check yesterday spent on the EC2 instances, because that's basically some reference if we do some big simulations and we should recheck our scaling algorithm and so on. So I will add a new visual with table, and basically I use instance type. Sorry, instance type spent, and I will see all the spends. But I actually care only about the yesterday, but I need to add the start time dimension, right? So now I have a couple of days here, but what I actually really care is only yesterday. So I will add filter. And I will say I care only about relative dates, previous day, and there should be only yesterday day, only for this table. So I know yesterday we spent $90. It's probably still okay, but I want to be aware of that. And now I can publish the dashboard, and what I can do is actually I can set up a couple of alerts based on this value. So it will not only go into my email every morning, I will create alert. So I can say create alert, and when the value is about 150, I will get alert. I can do also another alert for 200 just to be sure, or based on your usual spending and so on. So a couple of alerts, and you can sleep much better, especially when you could spend thousands of euros per day, right? So you really have to have it under control. So in like 5 minutes we create dashboards, operational dashboards where you see hourly spending, you set up the first alerts, and now let's go to the more advanced feature. Some of them are, go to the dashboard analysis again. So one of the feature which could be useful, but of course it's kind of AI or some linear regression. You can change this to the daily, because let's say we now care about daily, and you can add forecast. So if I will use a couple of days, AWS is trying to give you some forecast of your spend based on the it's actually not here. It actually can provide you forecast, or other options is anomaly detection and stuff like this. So let's go to the anomaly detection and insights. So you can easily add any insights about your application. Sometimes it's of course bullshit, but sometimes it's really useful, especially when you wake up. You just drink your morning coffee, you want to check your insights, and you can sometimes have really good example is when you have more service than one. I will show you. Here is all services in our account. You can create insights, and for example, you can have anomaly. So let's have anomaly there. You can put uh, bottom movers, month-to-day change, and so on. So in just a couple of seconds, you can create really some overview, some insights. How is your application doing? And with this framework, you can then operate easily. But of course, don't forget about the ability to zoom in and zoom out. So for example, this is all services, but you don't care about Amazon EC2 now because it's majority of spend. You want to exclude, so you can check all the services, how much you spent, and you can explore it. So I will just check because I create some note. One cool stuff is, for example, now we have those EC2, but I care about how we spend during the weekdays, like what is the seasonality. So I basically can add heat map. So I want to see if Monday morning or Tuesday evening is the peak in our spend. So I prepare calculated field date of the week. Hour of the day. And of course the spend, that's why we are here today. Like this. And we can see the patterns, right? So the y-axis is days, x-axis is hours, and we can see in some cases what is pattern of your spend during the week. Based on that, you can, for example, pre-schedule some warming. You can do any other important decision. In this case, we don't see any pattern because we are in pilot phase with EC2s, but in many applications, it could be super powerful. And as I said, this is also super powerful with joining with the cloud data, cloud spending data and with application data. So you can add multiple data sets in your dashboards. Here you can see I have AWS billing and I have Mongo data, which are continuously going into the S3 as well. And I can, head-to-head see how many projects our customer created, in comparison how much we spend on the cloud. So that's what Martin said, you can use price per unit, you can observe what actually is ratio and if there are any strange anomalies. So again, really powerful things, what you can do here. So basically that's it. I also had some, as I said, forecast prepare, but it needs to have at least 1 month of data. That's why it didn't work. So if you have at least 1 month data, it can also provide you some forecast. But of course, it has just some limited ability. But in this way, probably I just show you, and maybe when you know your product or your tech stack, you can really explore and you can really go really deep in your spend analysis, spend reporting, spend alerting, and so on. So as you can see here, usually you will build a couple of dashboards for your technology or for your team, and you will share just with those people who really care about, for example, CloudWatch. You will not send, for the scientific team, but you will send it to operational team, so they should watch their costs. Basically, that's it for how you can build it for yourself, and I will just super quickly show the Kudos dashboard, which actually, when you see the architecture, it works in the really same way. So they are using under the hood cost and usage reports, putting into the data lake, S3, Athena, and Quicksight. But they pre-built also the dashboards with additional data, so they are using AWS Compute Optimizer, AWS budgets and story plans. So all powerful stuff which are under the hood for monitoring. And the result is actually quite brilliant, but I didn't ever deploy it into AWS account, but it's on my own roadmap. So how it looks like, this is a demo from the well-architected Cloud Intelligence dashboard. So you can see already prepared a lot of stuff. So let's, for example, go to the compute. So you will compute into your account, and you have really good description how much you will spend on EC2 instances, on-demand, spot, everything, normalized per hour. Some metrics I don't even understand, but of course when you would play with that, you would understand. And what is super important, also Martin mentioned a couple of times in the site, there are huge data transfer chapter where you can see your actually data transfer per your account, and you can even see from where to where you are going and how much gigabytes you use. So this is something AWS pre-prepared, but realistically the deployment of this will take you a couple of hours because you need to run a couple of scripts which they prepare in your account. So I'm also not sure how secure it is, but it's recommended directly from AWS. So just a quick look at what they prepare. There's a chapter for storage, backupping, everything. So everything is pre-prepared for you, and you can analyze it. DynamoDB and all other technology you can think about. So that's it. I just show you how you can play with Cloud data in Quicksight, and as an alternative, how you can use pre-built solutions from AWS directly. And basically that's it. Hopefully you will find it useful as well. Thank you. Any question?
You mentioned, or you have the MongoDB connection, but you mentioned that you're pushing data to S3. Are there any other possibility to get data to Quicksight, like any connectors or anything, or everything?
Yeah, there's
S3 and
there's super cool technology in Glue, which it's actually no-code technology. So, but it works for Dynamo. So you say, this is my Dynamo table, put it into S3 buckets. I can also show you later during the beer or something, but you can continuously put your Dynamo. Actually, that's we are doing for the BI part of our Quicksight. So we continuously, like every hour or every day, depends on how you really care, your Mongo or Dynamo to do S3, and then the crawler read it every hour and put it into the Athena, and Athena into the Quicksight.
But you still need to use the S3 and Athena. You cannot connect directly from Quicksight.
For the continuously, no. But yeah, that's actually recommended from AWS. That's how you should put your application data into Quicksight in the framework I mentioned. Okay, thank you. Any other question?
I have one. You mentioned that you receive some alerts, or you can set up some alerts. Is there any integrated way how to do some actions? Like, I don't know, if cost is about something, shut down the EC2 machines or something like that.
I'm not aware about that.
You have budget actions.
But budget action, but not for probably alert from Quicksight. It's from different technology. Not like from Quicksight to SNS, Lambda to something. Probably no, but maybe there's some hack, Or you can always read your email, but with some script, but you don't have to do it.
If you receive it in the middle of the night and in the morning it's 5 a.m. I know.
There are probably different also way how you can do it. Okay. Any other question?
So so you showed us how you see the spend of particular services, But are you using some tagging strategy in order to create some solutions for which you then track specifically the cost consumption?
What do you mean,
Like, let's say you have multiple projects and you want to track the consumption per project, not only per EBS and so
yes.
S3, etc.
They, in the billing section, but actually I didn't play with it too much, I will show you quickly. They provide you that you can create the billing per resource. And there are also the tags where you can filter. So if you will do it like that and you will create filter on tags, I'm 97% sure it will work. So, but I didn't try it. So you can basically make word closer or filter on the tags, for the product A or product 2, and you can create dashboards, EC2 product 1, EC2 product 2. As I said, the export is providing over 100 column, so maybe you can, there is resource tag, so it will tell you the given row will be just for given tag.
I know it works, but I was more curious, like if you and in your company are you?
No, not it.
Okay.
Okay. Any other question?
What is the pricing model for this whole thing?
Yeah, so Quicksight is like $9 per user per month, or you can pay by session. Athena is super cheap because you have some free tiers, and usually if you have only this and maybe one dynamo table query, it's usually like $0. But of course, if you would use it in scale, you pay per query gigabyte, like in Snowflake or BigQuery, and then you pay something for Glue, like the crawler which takes the data every day. You pay like per some unit, but it's in single-digit dollars or even less per month. So let's say, okay, depends on how many users you will have in Quicksight. If you will have 1,000 users, it will be a lot of money.
But isn't that in Quicksight you have those users who are, let's say, just consumers, and then you have creators, which are more expensive?
Yeah. You can go. As I said with Lambda, the pricing is not easy again. Because you have also enterprise level and standard level of Quicksight. So I recommend to check it out for yourself because there are a lot of nuances.
For most of the cases, you can just schedule the export and export it as a PDF and send it by mail, right?
Yeah, exactly. That's what I do. Okay. That's it. Right. Thank you very much.
Okay, so I would like to thank our three speakers for sharing their insights and experience with cost optimization. Also, I would like to thank all of you for joining us today. We try to do these meetups every 3 months. I think the next one will be after summer in September, so if you want to stay up to date, we always share it on meetup.com, on AWS User Group Bratislava, or on our LinkedIn at Labyrinth. So you can follow us there as well, and we hope to see you next time. There will be some more pizza coming, some more beers coming, so just stay as long as you like and for some networking. And thank you.